Life on Earth breathes in the atmosphere and it breathes out different gases, and that causes a cycle, in our case of oxygen and CO2, which leaves a very distinct signature in the atmosphere. Now these so-called biomarkers are the things that we are looking for also in other planets outside our solar system when we're hunting for life. Now already we can detect molecules in planets that are much larger than the Earth and much closer to the stars, so they're much warmer. Now with the Plato satellite we will also hunt for Earth-like planets in the habitable zone, so they can have liquid water on the surface. And once we've found them, we can also start looking for biosignatures in these planets. Now here at SRON we are working at the next step, which is trying to analyze the light reflected from an Earth-like exoplanet. Now these planets are much smaller and therefore extremely faint, so they're like 10 billion times fainter than a central star. So you need an extremely sensitive detector. And next to that we also need a good color resolution. So a normal detector has 3 colors on each pixel. Now we are building a detector that has hundreds of colors on each pixel. And that allows us to identify the biomarkers in this extremely weak signal. To do this, we also cool the detectors to cryogenic temperatures, close to absolute zero. Now when we finally have this instrumentation on a space telescope, we will be able to identify the biomarkers in an Earth's twin. Now this is not the only research we do here at SRON.
Apart from this search for a second Earth and the possibility to have life on such a twin of our own Earth, we actually also want to understand the origin of the universe. So from the start of the universe, the Big Bang and what followed, and for instance the formation of the galaxy in which we live ourselves, which is the Milky Way. In order to answer those questions, we need advanced new instruments that are extremely sensitive, and for that we have to develop new technology, which we do in our laboratory. We do that by working together with many different partners across the world, and in particular with agencies like NASA and ESA, who actually launch the telescopes that register the information that comes from the universe. Apart from looking up and studying the universe, we also look down towards Earth, because space is a great place to study our planet. And that is very important for society because, for instance, you can study the composition of the Earth's atmosphere to look at greenhouse gases and small particles called aerosols. And both are important for us to understand and predict the future of climate on Earth, and which is of course very important for the survival of humanity. The other important aspect of this is that air quality can also be studied, and that has a very strong impact on human health. What excites me most is the thrill of discovery. There are many fundamental questions that humanity is asking, and to be part of big international teams that help to answer those questions and to bring humanity forward, I think is a privilege.